let's get started today. Right, so as I mentioned, today's lesson is the nervous system lesson, which is one of the systems of the body. So that's why it's covered in the anatomy and physiology workbook, and we are covering the level 3 side of the nervous system. So the first half of the lesson is a slight recap on the level 2 nervous system. We are covering 3 session aims for the first half of the lesson. We are going to describe the role of the central nervous system, describe the role of the peripheral nervous system, and this branches off into the somatic and autonomic branch, so we would talk about that also. And then finally, for the first half, describing the sympathetic and parasympathetic systems. Okay, let's move on. So the structure of the nervous system. The nervous system itself is made up of the central nervous system, which is the image on the right, which consists of simply your brain and your spinal cord. So your central nervous system is called your central nervous system as it runs down the middle. As we can see here, it's just your brain and your spinal cord. It's very important, however, that that is not damaged, as we know that any damaged trauma to the brain or to the neck area, to your vertebrae, can leave you paralyzed or even worse sometimes. So central nervous system, brain, and spinal cord. The other branch of your nervous system is your peripheral nervous system. And as you can see on the image on the left, it is everything else that is not your brain and your spinal cord. So you're looking at your arms, your hands, your legs, your feet, and your whole torso. So your nervous system will control your whole body. But remember, the central nervous system is just the brain and the spinal cord. Peripheral is your arms, legs, rest of the body. Your peripheral branch actually branches off into a further 2 branches, known as the somatic branch, which controls voluntary movements. So when you want to move your body, walk from A to B, perform a squat, perform a bicep curl, you would be using your somatic branch as we are controlling that movement. It is a voluntary movement. As part of your peripheral branch, you also have an autonomic branch. Now, the autonomic nervous system branch controls internal organs and glands. So you'll be looking at things like your lungs, your heart, your stomach, your bladder, or internal glands, internal conditions of the body. And if you can see here, this autonomic branch branches off further into our last 2 branches of the nervous system. So your controls of your internal organs and glands can be controlled by either your sympathetic nervous system or your parasympathetic nervous system. The sympathetic nervous system kicks in, is predominant when it needs to excite or bring action to the body. That's why it gives an arousing effect. The parasympathetic nervous system is more so for resting and digesting, therefore bringing a more calming sensation to the body. Okay, let's move on. So the nervous system as a whole will control voluntary and involuntary actions of all bodily systems. So it's going to control those voluntary actions through the somatic nervous system branch, and it's going to cause involuntary actions of the bodily systems through the autonomic nervous system branch. The nervous system will maintain homeostasis. So homeostasis was to bring balance to the internal conditions of the body. And it maintains homeostasis by exciting and arousing the body when we need to, and also calming the body when we need to. And it will do this through the sympathetic branch or the parasympathetic branch, which all comes from your autonomic nervous system, which controls the internal conditions of the body. The nervous system, I'll just like to add here, will also help maintain homeostasis by working closely with the endocrine system, which we talked about last week, the hormonal system. The hormonal system is also very important in bringing homeostasis and a nice condition, a balanced condition inside the body. So the role of the central nervous system at the brain and the spinal cord is to receive messages from all your peripheral nerves. So the brain will receive messages from all of those peripheral nerves. It'll send it to the spinal cord, which will then send it up to the brain, send the messages up to the brain. The brain will then interpret and analyze the signals and the messages and decide what to do from there. Once it decides what to do, it will send out a correct motor response and will start to speak to the peripheral nervous system to then start to move, contract some muscles, create the skeletal movement we want. The peripheral nervous system, so remember this is, if you look on the bottom right of the picture, these are all the other nerves in the whole body that is not part of the brain and the spinal cord. The peripheral nervous system receives information from sensory nerves. Sensory nerves will give you information from stimulus, which is from inside the body as well as outside the body. Maybe it's pain, maybe it's something's very cold or very hot. It's going to find this information and send it from, let's say, your fingertip all the way towards the middle of your body. And then when it gets to the middle of the body, it's going to send that information of pain or touch or heat or cold up to the central nervous system. So remember what happens with the central nervous system. We're going to analyze and interpret that information. And if it was pain from maybe touching something very hot, now we're going to send out the correct motor response through motor neurons. And we will now be able to move our hand out of the way from the hot object that we are touching. Are there any questions so far, guys, before I move on to the next slide? Just drop me a message into the question and answer box if there are any questions at all. Thank you very much to all of you guys mentioning happy to move on. Okay, let's move on to the next slide. So just to discuss the peripheral nervous system a bit more in depth. So remember, the peripheral nervous system is the nerves all around your body. Your arms, your hands, your torso, your legs, feet. So just as a quick recap, the peripheral nervous system, all the nerves across your body will have a somatic branch and an autonomic branch. So let's talk about that somatic branch again. The somatic nervous system branch, this branch is of the peripheral nervous system and is concerned with changes in the external environment. So when we think of external environment, think about movement. It's going to sense movement, it's going to sense touch, it's going to sense pain, skin temperature, and more. This is under our conscious control. Therefore, we are going to provide our own voluntary movements. So the somatic nervous system is under our own control. We're going to provide voluntary movements. Let's move on to the autonomic nervous system. So the autonomic nervous system, an easy way to think about it is it's automatic. The autonomic nervous system, what's happening inside of a body is going to automatically take place. once you swallow, let's say you take a bite of an apple and you swallow it, whether you want to or not, it's going to automatically digest that. It's going to once you do your initial swallow, peristalsis, the small contractions that take place through your esophagus, that's going to happen automatically, and your body's going to digest that automatically, isn't it? So autonomic does sound like automatic. That's the way I would remember it. Okay, so motor nerves that are under control of the autonomic nervous system are divided into two types. Remember, we had the exciting branch called the sympathetic branch, and we had the relaxing branch called the parasympathetic branch. So the sympathetic nerves is going to be there for creating action or exciting. Whenever the body needs to create action or excite the body, that branch is going to be predominant. That branch is going to be the one that's mainly kicking in. So everyone's heard of the fight or flight response, when your adrenaline kicks in. So when the body needs to fight or needs to run away, you're going to have increased heart rate automatically. Your cardiac output's going to increase. Your lungs are going to work harder. Your liver's going to release more glycogen into your bloodstream, so you have higher blood sugar levels, so you're ready to use that glycogen for your fighting or your running away, for your action needed. More forceful contraction of the heart, so you're going to have more blood flowing per heartbeat. Your blood vessels, your smooth muscle tissues like your arteries are going to constrict, therefore increasing blood pressure so the blood can move around to your targeted muscles better. When we do our exercises as well, so your standard type of hard workouts that burn a lot of calories and build up a lot of sweat, we're going to be predominantly waking up and using our sympathetic nervous system. When you are stressed out with a very demanding job, for example, you're always going to be on edge. Your sympathetic nervous system will be predominantly in action there while you're in your working place. Or maybe if you live in London and you're getting the London Underground tubes into work, that can be quite stressful. Your sympathetic nerves might be kicking in there also. So now let's move into your parasympathetic nervous system branch. This is for resting and digesting. It's going to be there to calm the internal conditions of the body and to relax. So the parasympathetic nerves in the parasympathetic branch are responsible for decreasing activities and are more active during times of relaxation and calm. So even though these two branches there's not one that's on and one that's off, they're always both working together to bring that homeostasis. Depending on the activity you choose and you do, one is going to be really predominant, such as 90% active, while the other one's in the back burner, only doing 10%. So if you are going to do your holistic type of exercise, or thinking of holistic lifestyle as a whole, if you are now looking into doing yoga classes where they dim the lights down, you're stretching your muscles, that's going to really start to predominantly use your parasympathetic nervous system. Your heart rate will come down, your breathing rate, the amount of blood you're pumping out, your cardiac output, these will all calm down, and also your resting and digesting will be able to take more of a place. Just imagine when you're doing interval training, when you're doing high intense interval training, you're not going to feel the need to go to the toilet whatsoever. Well, maybe if you're in a more calming environment, like doing some stretching exercises or just sitting down and resting, then your resting and digesting, urination, things like that are much more easier to come by. You can also think meditation. Meditation can help calming and waking up these parasympathetic nervous system, as well as just your recovery sessions where you might do some foam rolling to massage your muscles. and stretch. So it is important from an exercise perspective as well as a lifestyle perspective to have this balance of your internal conditions of your body. And you can do that by doing the different activities, whether it's your aromatherapy and you use light candles, you have a bath, things like this will start to really calm and relax the body by letting the parasympathetic nerves kick in. Okay, moving on. Okay, that was the first half of the lesson, which was just a bit of a recap from the level 2. So the central nervous system is the brain and the spinal cord. It's going to receive messages from your peripheral nervous system, analyze that, and then send the correct motor response back out to the peripheral nervous system. Your peripheral nervous system will receive sensory messages from either inside or maybe outside of your body, send those messages up to your brain, and then once the brain has analyzed it, it's going to send the correct motor response. So potential movement will take place after that. The somatic branch is for voluntary movements, such as moving your skeletal muscles, where you sit down, you move, you do a bicep curl, for example. But your autonomic nervous system is not under our control. It's more so just automatically happening within the body. The autonomic nervous system is more to do with your glands and your organs in your body. So your heart, your smooth muscle tissue, your blood vessels, your bladder, your stomach, your lungs. And the autonomic nervous system will branch off into two further nervous system branches. The sympathetic branch will increase, excite, arouse all of those glands and organs in your body by increasing heart rate, increasing breathing rate, increasing the blood being flowed, and it'll also restrict or inhibit your stomach from digesting and your bladder from going to the toilet, for example, because that's not important there and then. We need the blood flow and glycogen release for our exercise we're doing or our fight or flight we're doing. However, when we do relaxing activities or we're in a more of a relaxed environment, the parasympathetic nervous system from the autonomic system will be the predominant one in use. And now we can get to our resting, repairing and recovering of the body, as well as digesting. Okay, guys, so that was the first half of the lesson. Bit of a recap with extras. Any questions on that before I move on? Let's move on to the second part of the nervous system lesson. So these are going to be new learning outcomes, new session aims, directly for the level 3 part of the nervous system. So we've got 4 session aims now. We're going to identify the structure of a motor neuron and explain the role of the motor unit. We're going to explain the function of proprioceptors of the body, including the stretch reflex and reciprocal inhibition. And finally, we're going to talk about adaptations, so improvements that take place in the nervous system after we do training for a long time. So let's move on. So first things first, this is a diagram which shows you the structure of a motor neuron. We will cover each structure of the motor neuron one by one as the slides take place. But your nerves, you have lots of nerves in your body. And remember, we discussed that you have a sensory nerve which senses changes inside and outside your body and sends it up to the brain. And we also said we have a motor response or a motor nerve. So motor neurons, motor nerves directly will affect a muscle. So motor nerves will be for movement. motor neurons are very, very similar, but they might talk to another part of the body first before creating that movement of the body. But think about motor as movement. Look at the arrow on the bottom of this diagram. This will show you the direction of the electrical impulse and the direction the impulse travels through the nerve. So nerves are kind of like wires in the body, and wires connected to a light switch. They're very rapid. Once you flick on the light switch, the nerve, the impulse, the current going through the wire will flow through very quickly and turn on the light. It all happens in milliseconds. So you could think about your nervous system kind of like copper wires or fiber optic wires, if you might, with your Wi-Fi going on, or copper wires with your lights turning on. So just to chuck in here before we go into the structure of the motor neuron, I'll chuck in the all or none theory, all or nothing theory. With your nervous system, it either will contract the muscle or not contract the muscle. That's the all or none theory. So whether the impulse is strong enough to send the impulse all the way through and contract the muscle, or the impulse isn't strong enough in the first place and it's not even going to send the impulse. It's like the light switch. Do you turn the light switch on? Okay, the light is on. Or do you not turn the light on? Okay, it's off. There is no such thing as a dimmer switch and a half type of contraction. All or none theory is the muscle fully contracts because the impulse is going to contract all of those muscle fibers, or there's just not enough stimulus to do that. So just to chuck that in there as a bit of a recap on level 2 also. So looking at the structure of this motor neuron, you've got dendrites on the outside. The nucleus in the cell body is part of the main cell to begin with here. The axon is the really long pathway that the impulse can travel along. And you have the myelin sheath. This is made up of fat. So this helps the electric impulse conduct along through the axon. And at the very end of the motor neuron, you have the axon terminal. So terminal means the end. Terminus means the end. So let's go through the structure one by one. So the dendrites, these are the tree-like branch projections out here from the cell body. So these dendrites are branch-like projections from the cell body. They receive stimulation through neurotransmitters in order for the cell to become active. We'll talk about that at the very end of this structure. Okay, so they're going to receive neurotransmitter in order to light up, wake up, in order to send that impulse all the way down the line. The cell body here is also known as the soma. So the part that looks like an egg, this is the cell of the motor neuron. It's a spherical part, looks like an egg, and it contains the nucleus. So the cell body will connect to the dendrites, which brings the information down the axon, down the nerve. The nucleus would be the equivalent of the egg yolk. The nucleus is the main brain architect of the nerve cell. It contains the gene, DNA, and information to create that cell. So in particular, the nucleus has got DNA and information to make this a motor neuron. While in your sensory neurons, that nucleus there would have the DNA and information to make that a sensory neuron. Axon here, the main conducting unit of the neuron. So the axon is the long snake-like looking path where the impulse can travel, capable of sending electrical signals of distances up to 2 meters long. So your nervous system, just one nerve can send an impulse up to 2 meters long. Now, there's lots of different facts up on the internet. You know, I've read that I hear different things on the internet, but if you lined up all the neurons in your body, it could be nearly 1,000 kilometers long. Another source said, 60,000 miles long. So I know they're both completely different numbers there, 1,000 kilometers or 60,000 miles. But you get the gist. If you were to unravel all the nerves in your body, it's going to really cover a long distance. Now let's finally talk about the axon terminal. So the image has changed slightly, but it's looking exactly the same. Remember, the axon terminal is at the end of the motor neuron. This image down here shows two motor neurons. Okay, so let's talk about the axon terminal here. We are going to zoom into just one of them, but you got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them at the end of the motor neuron. So it's at the end of the neuron. It's the final part of the neuron to receive an electrical impulse. And it's also the area where the impulse is converted to a chemical signal. The chemical signal is called a neurotransmitter. And this is ready to transfer information to another neuron. So kind of like a relay race and handing over the baton. Right here at the axon terminal is where we're going to hand over the electrical impulse to the next motor neuron, to the next dendrites here, and then this second motor neuron can wake up and activate and carry on sending that signal across. So it does this through a chemical called a neurotransmitter. If we look at the image here, that is the relay race baton of handing the signal from one motor neuron's end, the axon terminal, to one motor neuron's beginning, the dendrite. The gap in between is called a synapse. The electrical impulse will be converted to a chemical known as a neurotransmitter. That's how it passes the information over, and once the neurotransmitter is sent to the new motor neuron, it will become an impulse again. Okay, let's move on to motor units. So we covered this in level 2 in the muscles lesson and the nervous system lesson. What is a motor unit? Well, let's have a look at this diagram first. A motor unit. So this is a motor unit. Let's look at all the different pieces on it. So you got the motor neuron. We just discussed the motor neuron, didn't we? And then you have branches of the motor neuron here. So the different branches are attaching to different fibers. See, this branch up top have connected to these two fibers. These two branches have connected to this fiber. And this branch of the motor neuron has connected to this fiber. Out of the main muscle fiber, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 muscle fibers in this particular diagram. And remember, muscle fibers are made up of bundles of myofibrils. So these 13 muscle fibers are made up of bundles of these myofibrils, and there's about 10 myofibrils per bundle. Okay, so what is a motor unit? Simplest way to describe what a motor unit is a motor neuron. Think of it as a motor nerve, and all of the muscle fibers it connects to. You're going to see different words. A motor unit is a motor unit, and all the muscle fibers it innervates, so basically activates. So it's one nerve and all the muscle fibers it activates. That is a motor unit. Okay, I'll give a few examples when we get to adaptations. Let's talk about sensory organs in the body. So the body is very special and is very clever to keep creating balance, that homeostasis in the body. It does this through sensors for change, And we have 4 different sensors in the body. These are all sensory organs in the autonomic nervous system. Remember, that could be excited or it could be relaxed. So chemoreceptors are there to detect changes in levels of chemicals such as carbon dioxide or calcium. You've got thermoreceptors, which detects temperature changes inside the body. You have baroreceptors, which detect changes in blood pressure. And then you've also got proprioceptors, which are found in muscles and tendons to detect changes in body position. So we're going to talk now about proprioceptors and link it with the nervous system. So we're going to talk about 2 proprioceptors. The first one we're going to discuss is the muscle spindles. So the muscle spindles, it's in the name, isn't it? Muscle spindles is located in the muscle. If you look on the picture here, it runs alongside the muscle fibers. The pinky red tubes are muscle fibers, and the blue, what we see here, is the muscle spindle in blue. What does a muscle spindle do? It detects changes in muscle length, and then it brings about a contraction automatically to prevent injury. So I'm going to repeat that. What do muscle spindles do? It detects changes in muscle length, and then it's going to bring about an automatic contraction to prevent injury. So an example of this would be the knee-jerk reflex that doctors used to do and still do. They get a hammer and they tap onto your patella tendon. And the patella tendon, by tapping onto it, it will actually stretch your muscle in your quadricep. So there we get the detecting change in muscle length. We've stretched it, and it's going to automatically contract, and your leg's going to kick up, isn't it? So you're automatically contracting, your leg's going to automatically kick up because it's detected change in muscle right near your knee. Doctors do this to see whether you are responsive, so whether you got damage in your quadricep, or maybe the opposite, you're too responsive. Another example of how muscle spindles will work could be throwing a ball. You know, it could be just a normal throw. You could be thinking baseball or cricket. When you wind up and you stretch your arm backwards, it's going to detect the change in muscle length. And then there you go, you're ready with a reflexive contraction to throw the ball and sling it as far forward as possible. Okay, before I move on to our next proprioceptor, just want to stop and see if there's any questions. Right, thank you all for your quick, prompt messages. All happy. I'm loving to see that you guys are all happy today. Okay, cool. Let's move on. Second and last proprioceptor we're going to talk about is the Golgi tendon organs. Okay, Golgi tendon organs. Again, it's in the name here. Golgi tendon organs are going to be found in the tendon. Okay, so they are located in the muscle tendon. They detect increase in muscle tension. Then once there's too much tension in the muscle, in the tendon, then it's going to automatically bring a relaxation of the skeletal muscle to prevent injury. So let me say that again. Golgi tendon organs will detect an increase in muscle tension in the muscle, in the tendon, because they're all connected together, as you can see here in the picture below. And once it detects this increase in muscle tension, it's going to bring a relaxation effect to the skeletal muscle to prevent injury. So I could give a few examples here. Let's say you are attempting a 1 rep max. So let's say we're trying to lift up 150 kilos, very, very heavy weight, doing a deadlift. So you grab it, you get into position, you're trying to lift it, you got so much tension going all over your body, All your Golgi tendon organs have detected all of this increase in muscle tension, but you're just simply not going to be able to lift it up. It's going to bring a reflexive reaction to your muscles in order to prevent injury. So that's one way to look at Golgi tendon organs. Let's say we are actually able to do the 1 rep max. So now let's say we're doing a back squat. It's a heavy weight for yourself. I'll just use 100 kilos as an example, as that is quite a heavy weight for a lot of people. So you're doing 100 kilos for 1 rep. As you go down into the squat, your hamstrings get really overloaded. There's a real big increase in muscle tension in your hamstrings, and therefore there's a big increase in muscular tension in your tendons, in your hamstring tendons as well. So your Golgi tendon organs will not want your muscles to get damaged under all of this contraction, so it will loosen up a little bit so you can get that extra, 1 inch lower before you go back up. That's the second example. A third example, and this will link in with your workbooks under a stretching question. So in your workbooks, it talks about different stretches and risks and benefits and when you'll use them. You got your static, you got your dynamic stretches. You do that before a workout. You're mobilizing, you're moving your muscles, preparing your muscles for movement. You have one specific type of stretch called a PNF stretch. PNF. It stands for proprioceptive. So, we're talking about proprioceptors now. PNF stands for proprioceptive neuromuscular facilitation stretching. Neuromuscular meaning nerves and muscles. So you might have seen personal trainers stretching out your clients at the end of a session. I'll use the hamstring stretch as an example. And I'm going to use 2 examples here, which will help you with your workbooks. There's 2 types of way a PT can help out the stretching at the end. And I'm going to go with the easy one first, which doesn't require much skill from the trainer. You simply, on a hamstring stretch, you get into position, get your client to say, leg up, please, keep the leg straight. And you as a trainer would slowly and, safely push the leg back towards their torso or towards their head, so the client will feel the stretch in the hamstrings. That is called a passive stretch, because you as the personal trainer are passively moving the leg for the client. Now let's talk about the complex one, the PNF, proprioceptive neuromuscular facilitation stretching. You're going to start off in the same way, and there are different guidelines in how to do this. You'll probably see a few different sources, but I'm going to tell you one of them that I know of. So you get into the hamstring stretch position. Client, please lift your leg up for me. You're grabbing them by the heel of the foot of the shoe, and you're pushing them to where you can feel that they're getting a good enough stretch. So on a scale of 1 to 10, RPE scale, they're not in pain, but they can feel it. They're slightly uncomfortable. Might be like 7 out of 10, for example. You're going to hold that stretch position for 10 seconds. After 10 seconds, you're going to ask your client to push their heel into your hand, and you're going to push at their heel. So you got a isometric contraction going on. They're pushing, you're pushing, but there's no movement happening at the leg. You are increasing tension at their tendon. You will do this for 6 seconds. After 6 seconds takes place, this is where it requires a lot of skill from the PT. You need the client to relax, breathe out, and you as the trainer have got to push for a further range of motion, all while being safe and not over pushing, all within a split second, and you will automatically trick the body, trick the muscles and the tendons to get more flexibility instantly. So that PNF stretching can be a really good one to use with clients, as they can notice an increase in flexibility straight away, albeit it might be kind of temporary. So that is an example of the Golgi tendon organ, PNF stretching. You're going to fight against each other for those 6 seconds. It's going to detect an increase in muscle tension. And then because it's detected an increase in muscle tension, once the client does relax, you're going to be able to push it further because the Golgi tendon organ has automatically brought a reflexive relaxation to the muscle. Any questions on that, guys, before I move on? F stands for facilitation, Stacy. Proprioceptive neuromuscular facilitation stretching. Okay, lots of happy people. I guess I'll just drop in one quick thing before we move in. As I talked about passive stretching, I talked about PNF stretching. There is a question in your workbooks that talks about active stretching. So I want you guys to just try this right now. You might be sat down. If you can stretch your legs out in front of you, I want you to actively bring your toes towards your knee. Toes towards your knee. So we are dorsiflexing at our ankle. If you bring your toes towards your knee, you should feel your shin muscles contract. So if you are stretching your shin muscles, you are automatically, if you're contracting your shin muscles, you are automatically relaxing your calf muscles. So active stretches means you're actively contracting one muscle to relax the other side. Just wanted to drop that in as a bit of an extra. Okay, let's move on. And that links in perfectly with reciprocal inhibition, really. Reciprocal inhibition means when one muscle is contracted, its opposite muscle, so the opposite muscle is the antagonist, is automatically inhibited. Simply put, when one muscle is on, the opposite muscle is off. There's no way to contract your biceps and your triceps at the same time because then you won't get any movement in the body. So it's really important for just general movement of the body that one muscle contracts, one muscle relaxes. So this is a good example here, you know, when you do a bicep curl, obviously your biceps are working hard. That's the prime mover. That's the agonist muscle. And your antagonist, your triceps, will relax. The opposite, you know, you're contracting your triceps, your biceps will be absolutely relaxed. I just used the example for active stretching. When you do your toes towards your knees, when you dorsiflex at your ankle, your shin muscles, your tibialis anterior will contract, therefore giving a nice stretch to your calves. And it's not a tough stretch, is it? When you pull your toes towards your body, it's a nice, easy stretch. You're not going to really get injured off of it. Okay. Why is this relevant to exercise? We need one muscle to contract and one muscle to be turned off so we can move. If this didn't happen, we were unable to move. That's why it's relevant to exercise. However, there are some muscles that are harder to stretch or harder to activate even. A good example is the kneeling hip flexor stretch. So it looks like a lunge position. Your knees on the floor, you look like you're in a lunge position, and you push forward at the hip in order to stretch your hip flexors. If you're getting technical, I guess you're trying to stretch your iliopsoas group, your iliacus muscle, as well as your psoas major muscle. Some people who are already quite flexible might get in the position and say, I cannot feel the stretch. So you might have to cue them, you know, into engaging their core, then push the hips forward, maybe raise the hand up in the air to open up the psoas muscle. You might still get them saying, I still can't feel the stretch. This is where you can use reciprocal inhibition. So your hip flexors are your front of your hip. What's opposing your hip flexors? So if your hip flexors are your front of your hip, what's behind your hip? It's going to be your gluteus maximus. So this is where you say, okay, if you can't feel the stretch in your hip flexors, contract your glute, squeeze your bum, squeeze your glute muscle. And by turning the glute on, now the psoas and the iliacus, the hip flexors, are off. Then you can get more of a stretch. So you can use reciprocal inhibition like this to try and activate more, to get better stretches. Okay, final slide. So improvements of motor recruitment, adaptations of motor recruitment. Your nervous system will improve not just with weight training, with cardio training, for example, but you do wake up a lot more. You can give a lot more stimulus by doing weight training, and the heavier the weight you go, you're going to be giving more and more stimulus to the muscle fibers and the nerves and the nervous system. Remember, all systems in the bodies do work together. So let's say we've been doing a very well planned out periodized program where you might start with light-ish weights for 1 month, then you go on to medium weights for the second month, then you go on to heavy weights for the third month. You definitely will see improvement. You'll be getting stronger at all of your exercises due to your nerves getting better, improving, and we'll talk about this here. Not just your muscles getting bigger, it will also be because of your nerves improving. So why are you getting stronger? It will be due to things such as this. The frequency of nerve impulses coming into the muscles will improve. So you're going to increase the frequency of nerve impulses coming into the muscle cell. So if you think about with Wi-Fi, back in the day, they used to just run copper cables for Wi-Fi, and then now we got fiber optics cables. So you're going to be able to send the signal much faster in your new and improved fiber optic nerves, in a sense. Your nerves are just going to improve in general. You're going to have improvement in neural pathway, which isn't listed here, but just like tree branches, you're going to open up more nerves to connect to more muscle fibers. The second point here, the number of motor units activated is going to improve. So I'm going to use an example here, bench press. You're lying down on your back, you've got a big barbell above your head, above your chest even, sorry about that. So you're doing bench press, barbell over your chest, and you're performing reps. Now, some of you guys might have experienced this where you're doing a bench press and you get all the way to the bottom of your chest, and when you try and push it up, you get stuck. Or in any exercise, maybe you're doing bicep curls with a barbell, and on your last rep, you pull up and you get stuck. Okay, so let's say you're in the bottom of the bench press and you're stuck. Two things are going to happen. You're going to fail, and you need a spotter to come and help you because you failed. There's no way of getting that out. Or there are sometimes times where, you say in your brain, I can do this, and you really push through and you manage to get that rep out even though you were stuck. Why have you managed to get that rep out? You've activated more motor units. So your pectorals, you will be also using your deltoids and your triceps in a bench press, but let's just say pectorals for easiness. It's a large muscle group. There's loads of muscle fibers there. So you're going to have loads of nerves attaching to loads of muscle fibers. Let's say, just for argument's sake, just easy numbers here, you've got 15 motor units attaching to thousands of muscle fibers to do the bench press. But when you get stuck, you're going to wake up more motor units. So those 15 motor units you had, you're stuck now. Your brain's going to be calling for help, and now it's going to wake up an extra 5 more motor units. So now we've got 20 motor units in total. We're using another 1,000 muscle fibers out that have been woken up, and now we get the rep out. So that's some improvements that can take place as you are performing, progressively overloading, trying heavier weights, trying more repetitions, and working to higher RPEs. Finally, with your motor units, if you can turn them on and they're all being activated through your hard training, they will all turn on at the same time now. So that's a really big improvement for power. When you're trying to do a 1 rep max big heavy deadlift, or maybe you're doing your Olympic clean and press type exercises, you're able to turn on all your nerves and muscle fibers that you want to turn on at the same time. There's no lazy ones. I know exactly which ones I want to activate, and I'm going to activate them all at the same time. Now I can give my best effort, my best power output. So guys, that was the second part of the nervous system lesson. We discussed the structure of the motor neuron. You start off with dendrites, which will be the start of the electrical impulse down the motor neuron. You have your cell and your nucleus, which makes it the motor neuron in this example. The impulse runs along your axon, and then you got your axon terminals where the impulse will change to a neurotransmitter and pass that signal on to your next motor neuron. So you could keep passing this impulse down the line until where it needs to. The motor unit is a motor nerve and all the muscle fibers it attaches to. We need it for muscle contraction. The stretch reflex is a proprioceptor in your muscles. It detects the muscle spindle. The muscle spindle is a proprioceptor found in the muscle. It detects change in muscle length and brings about a contraction to prevent injury. Your Golgi tendon organs are found in your tendons. They detect an increase in muscle tension to prevent injury. Reciprocal inhibition is when the agonist is contracted, the antagonist is relaxed. Muscles work in pairs. When one is on, the other is off. And we just talked about long-term adaptations that take place in the nervous system. I just flick back here. The frequency of nerve impulses are going to increase. So your impulses are going to be stronger and faster. The number of motor units activated, you're going to wake up more nerves attaching to more fibers. And now they've been woken up, you can use them all better at the same time. The synchronization of motor units, they're all going to wake up, they're all going to perform, help you do that big lift. So that was the end of the nervous system lesson. Any questions to take in, guys? Guys, before you go, I'm just going to copy and paste the next lesson on Thursday on muscles. Please register to it. And everyone is looking happy, which is good. I'm going to go and take a live workout in 5 minutes, so that's perfect timing. There is a link there that I've just dropped. Please register for Thursday's 10 a.m. muscle lesson. And I shall see you guys then. If you have any questions from now until Thursday, you know where you can get me. Be checking my emails today and on Wednesday. matt@educatefitness.co.uk. Right, have a good, happy, sunny day, guys, and I'll see you on Thursday. Bye for now.